Hello and welcome to week 10, lesson 3, the last lesson of the week. Today we're going to be looking at domain, range, and function notation. At the end of this lesson, I'm hoping you'll be able to identify the domain and range. You'll use function notation correctly, and you'll be able to evaluate a function. Little recap, you've talked about this function machine before. It's something that does the same thing to all the inputs that you put in and gives you the outputs. Okay, so we're going to take a look at that a little bit deeper. We talked about how these were the inputs. 5, 6, and 7 were inputs, or X values, and the 19, 16, and 13 were outputs, or Y values. There's another word, domain. That means your inputs, X values. It means basically the same thing. It's also an independent variable. We choose that one. Depending on what we choose is what comes out. And those are the range numbers, and also the dependent variable. So those numbers depend on what you put in. Okay, so we could write this set of ordered pairs as a relation, like you see here, 5, 13. When you put 5 in, you get 13 out. 6, 16. When you put 6 in, you get 16 out. 7, 19. Or I could list them as the domain and range. The domain here would be 5, 6, 7. Those are all the numbers that we put in. Those are only X values. And the range, 13, 16, and 19. It's kind of like the mapping diagram that we did in the last lesson. All right, so what's function notation? Function notation is a naming convention for a function rule. So you'll see this a lot. F of X, or F parentheses X, equals a function rule. And that function rule is going to be some algebraic expression. F is not a variable. It is the name of the function. X is the variable we choose for our inputs. The function rule, like I said, is an algebraic expression. And we read it f of x. That's what I said when I first popped this up, f of x. Okay? Now, we're going to look at something that you've done in the past, equations, and compare it to functions. And how are they alike and how are they different? So here's an example of an equation. And here's an example of a function. You can see that they're almost the same. They're exactly the same on the right-hand side, 3x plus 5 and 3x plus 5. On the left, though, with an equation, it's just a number, and you get one solution here. With the function, it's a function rule or a function notation. I could put many different numbers in for x and get many different y values. So equations, you get one answer a lot of times, and functions, you can get many different inputs and outputs. Here's another example, and that's how you would write it as a function. Replacing what it's equal to with the name of a function. Another example there. And those, notice how I used f, g, and v. They're not variables. Those are just names. So this is the name. This is the function f. This is the function g, and this is the function v. Okay. Like I said, equations typically have one solution, and functions have many inputs and outputs. So we're going to evaluate a function now. So evaluate g of n for n equals 10. So a lot of people have a hard time understanding what I'm asking you to do here. Well, g of n equals 5n plus 3. What I'm telling you is I want you to put 10 in for n. So g of 10 is how you would read that, g of 10. That doesn't mean we're doing 10 times g. It just means I'm putting 10 in anywhere I see an n. Well, I see an n on the right-hand side, so I'm going to put 5, and I'm going to put 10 in for n plus 3. And the left side doesn't change. It's just g of 10 equals, and I'm starting to simplify the right-hand side. 5 times 10 is 50, and then 50 plus 3 is 53. So g of 10 equals 53. Okay. Find the range of the function. Given the function f of a equals negative 4a plus 12 for the domain negative 3, 0, 6. And if you understand the vocabulary here, it's not too hard what I'm asking you to do. Domain means x values. So I'm putting in negative 3 for my independent variable, which in this case is not x, but it's a. So these three numbers here represent my a values. So f of negative 3 would be negative 4 times negative 3 plus 12. Well, negative 4 times negative 3 is 12, plus 12 is 24. Do it again with 0 this time. So f of 0 is negative 4 times 0, which is 0, plus 12, which is 12. And do the same thing with 6. F of 6 is negative 4 times 6, which is negative 24, plus 12 is negative 12. Then I wanted to find the range. So the range is all of my y values or my outputs. So 24, 12, and negative 12. All right, so now this one's going to have a couple different functions. Use the functions f of x equals 2x and g of y equals y squared plus 1 to find the value of the expression f of negative 7 plus g of negative 4. So we got a lot of steps here, but all we're doing is we're taking negative 7 and putting it in for x in the f function, which is the first one. And then we're going to take that answer and we're going to add it to the answer that we get when we put 4 in for y in the g function. So let's start with f of negative 7. I'm putting that in for x. So 2 times negative 7 is negative 14. I'm going to hold on to that. Now I'm going to do g of 4. Put 4 in for y. I get 4 squared plus 1. 4 squared is 16. 16 plus 1 is 17. So f of negative 7 is negative 14. And g of 4 is 17. So negative 14 plus 17 is 3. So my final answer here is 3. Example 4 is a word problem. Evan goes to basketball practice Monday through Friday for 2.5 hours each day. How many hours does he practice in 1 week, in 2 weeks, in 3 weeks? So the first thing I'm going to do is I'm going to write this as a sentence. What's going on here? In 1 week, he practices 2.5 hours times 5 days, because there's 5 days in a week. And that gives me the total hours that he practices in 1 week. In 2 weeks, he practices 2.5 times 10 days, because that's how many days are in 2 weeks, equals total hours. 3 weeks, you see what happens there, and hopefully you start to see a pattern. 2.5 is consistent. It's in there every single time. Total hours is consistent. The number of days changes. Okay, so algebraically, we're looking for what changes and what stays constant. So 2.5 stays constant, so I'm going to leave that there. Times the number of days, and that equals the number of hours. So the number of hours is going to change, right? And the number of days is going to change. But the number of hours, total hours, is dependent on, or the y value, the number of days, which is the x value. So we're going to say x is the number of days, which means f of x, or the y value, is the total number of hours of practice. So when we write it as a function rule, you get f of x, or the total number of hours of practice, is equal to 2.5 times the number of days. And then you can figure out, in 1 week or 5 days, 2.5 times 5 is 12.5 hours. 10 days is 25 hours. And 15 days is 37.5 hours. You can see you get multiple data points there. That concludes week 10, lesson 3. You'll be moving on to your assessment pretty soon.